The F-35 Joint Strike Fighter is not just another military aircraft, it's the most advanced and expensive weapon system ever built. With a price tag approaching $2 trillion over its lifetime, the F-35 program has redefined the boundaries of defense spending. This jet combines unmatched stealth, cutting-edge sensors, and the ability to engage multiple targets simultaneously. It's a flying supercomputer capable of performing missions that once required entire fleets. But behind the sleek exterior lies a story of delays, cost overruns, and technical challenges that have made it one of the most controversial defense projects in history. So, is the F-35 truly worth its astronomical cost? The journey to the F-35 began long before the first jet took to the skies. The end of the Cold War in the early 1990s brought about a shift in military thinking. The world was changing, and so were the threats. The United States needed a new aircraft that could meet the demands of modern warfare, something versatile, technologically advanced, and capable of replacing multiple aging fleets across the Air Force, Navy, and Marine Corps. The idea was simple, yet revolutionary: create a single aircraft platform that could perform a wide range of missions for different branches of the military. The goal was to design a fifth-generation fighter jet that could handle air-to-air combat, ground attacks, reconnaissance, and electronic warfare. This new fighter would be stealthy, fast, and deadly, with the flexibility to operate from conventional runways, aircraft carriers, and even short, rugged airstrips. But why did the US need such a multi-role aircraft? The answer lies in the evolving nature of global conflict. No longer were battles fought in clearly defined theaters with uniformed armies. The threats were becoming more diverse, ranging from rogue states to terrorist organizations. The military needed an aircraft that could respond to a variety of scenarios, whether it was patrolling the skies over friendly territory or engaging in combat deep behind enemy lines. Thus, the F-35 Joint Strike Fighter program was born. Conceived as a collaborative effort between the US and its allies, the program aimed to create a fighter jet that could meet the needs of multiple services while also being cost-effective. The idea was to share technology and development costs across several nations, reducing the financial burden on any single country. However, as with any ambitious projects, the reality proved far more complex than the initial vision. The F-35 was not just one aircraft, but three distinct variants, each designed to meet the specific needs of the Air Force, Navy, and Marine Corps. The F-35A, for example, was developed for the Air Force as a conventional takeoff and landing aircraft. The F-35B was designed for the Marine Corps with short takeoff and vertical landing capabilities, ideal for operations from amphibious assault ships. The F-35C, on the other hand, was tailored for the Navy with larger wings and reinforced landing gear to handle the rigors of carrier operations. The complexity of designing a single aircraft platform that could perform all these roles led to significant engineering challenges. The initial goal of achieving 70% to 90% commonality among the variants quickly proved unrealistic. As development progressed, it became clear that each variant required its own set of unique components, driving up costs and complicating the production process. Despite these challenges, the F-35 program pressed forward, with the first test flights beginning in the early 2000s. But as the aircraft took shape, so too the scale of the program's ambition and its price tag. At the heart of the F-35's design is its stealth capability. Stealth technology is what allows the F-35 to avoid detection by enemy radar systems, giving it a significant advantage in combat. But how does it work? The F-35's shape, materials, and internal weapon bays all contribute to reducing its radar cross-section, making it nearly invisible to radar. Unlike older aircraft that carry weapons on external pylons, which increase radar visibility, the F-35 stores its weapons internally, maintaining a sleek, low-profile design. The F-35 also features advanced sensors that provide pilots with an unparalleled view of the battlefield. The Distributed Aperture System, DAS, for example, is a network of cameras mounted around the aircraft that gives pilots a 360-degree view, even allowing them to see through the airframe. This system, combined with the F-35's powerful radar and sensor suite, provides a level of situational awareness that's unmatched by any other fighter jet. But what really sets the F-35 apart is its ability to fuse all this information into a single, coherent picture for the pilot. The aircraft's avionics system collects data from its sensors, processes it, and presents it to the pilot in a way that's easy to understand and act upon. This reduces the pilot's workload and allows them to focus on the mission rather than managing complex systems. The F-35's cockpit is another example of cutting-edge technology. The traditional heads-up display found in most fighter jets has been replaced with the Helmet-Mounted Display System, HMDS. This system projects critical flight information directly onto the pilot's visor, allowing them to keep their eyes on the target at all times. The HMDS is also integrated with the aircraft's sensors, enabling pilots to lock onto and engage targets simply by looking at them. The F-35's engine is one of the most powerful ever built, capable of propelling the aircraft to speeds of over Mach 1.6. The F-135 engine is not only powerful, but also versatile. In the F-35B variant, it's coupled with a vertical lift fan that allows the aircraft to take off and land vertically, a feature that's essential for Marine Corps operations. However, this added complexity has also made the F-135 one of the most expensive and challenging components of the F-35 program. As impressive as the F-35's technology is, it hasn't come without significant challenges. The software that runs the aircraft's systems is among the most complex ever developed, with over 8 million lines of code. Ensuring that this software functions correctly has been a monumental task, leading to delays and cost overruns as developers work to iron out bugs and integrate new capabilities. One of the most persistent challenges has been the F-35's thermal management system. The aircraft generates a significant amount of heat, especially during high-intensity operations. Managing this heat is critical to maintaining the performance and longevity of the F-35 systems. However, the current cooling system has been pushed to its limits, requiring upgrades to prevent overheating and ensure the aircraft's reliability. The cost of maintaining the F-35 has also been a major concern. The advanced materials used in the aircraft's construction, while essential for stealth, are expensive and require regular maintenance. The F-35's engine, too, has been a source of ongoing costs, with issues related to reliability and wear driving up the price of keeping the aircraft in service. The F-35 program has faced a series of technical challenges that have contributed to its staggering cost. Initially projected to cost around $233 billion, the program's price tag has ballooned to over $442 billion in acquisition costs alone. But that's just the beginning. The lifetime cost of operating and maintaining the F-35 fleet is now estimated to exceed $1.7 trillion, making it the most expensive military project in history. So why has the F-35 become so costly? Several factors have played a role. The complexity of the aircraft's design, the challenges of integrating advanced technologies, and the need to develop 3 distinct variants have all driven up costs. Additionally, delays in production and testing have added to the program's expenses. Inflation has also played a part, as rising costs for materials and labor have pushed the program's budget higher. One of the biggest cost drivers has been the need to continually upgrade the F-35 systems to keep pace with emerging threats. The Block 4 upgrade, for example, is expected to add significant new capabilities to the F-35, but it has also encountered delays and cost overruns. The F-35's engine is another source of ongoing expense, with the Pentagon considering a multi-billion-dollar effort to upgrade the engine's cooling system to improve its performance and longevity. The high operational costs contribute significantly to the program's total expenses. For example, the cost to operate an F-35A is approximately $38,000 per flight hour, which has been a point of criticism and concern. Despite these challenges, the F-35 remained a critical component of the U.S. military's future air strategy. Its advanced capabilities make it a formidable weapon in the skies, but its high cost raises questions about whether it's truly worth the investment. Is it a triumph of modern engineering, or a cautionary tale of runaway costs? Only time will tell. If you enjoyed this video, don't forget to like this video, subscribe to our channel, and hit the notification bell to stay updated on our latest content. Hey.